The topic of this video is another reaction involving alcohols, and it's their oxidation. And in this text, what you normally get for the reaction is a symbol, like so above that arrow, an O in brackets. And that means oxidation. O for oxidation. But the reagent that's used synthetically or in a lab is potassium dichromate, so C2Cr2O7. It's an inorganic compound. It's a strong oxidizer. But generally, the O in the brackets is what's used as a shorthand. So what are the products of alcohol oxidation? Recall from an earlier video that this is a primary alcohol because the carbonyl carbon, the carbon that I'm highlighting in red there, is only bonded to one other carbon atom. So this is a primary alcohol. It will be oxidized to a carboxylic acid. Notice the change. The carbon atom, again highlighted in red there, lost two hydrogen atoms, two carbon-hydrogen bonds. When you lose hydrogen atoms, it's like losing electrons. That is oxidation. So it undergoes 2 rounds of oxidation, lost 2 carbon-hydrogen bonds. There are reagents that exist where that will only undergo 1 round of oxidation. See, lose 2 carbon-hydrogen bonds. This reaction, lose 1 carbon-hydrogen bond. And you get an aldehyde. Because that carbon atom still has 1 carbon-hydrogen bond. This is done with a milder oxidizer. But in this particular text, the big focus is on the production of the carboxylic acid. Strong oxidizer means that that carbon is completely oxidized, losing its 2 carbon-hydrogen bonds. Secondary alcohols, draw an example. Only have 1 carbon-hydrogen bond on the carbonyl carbon as indicated here. When they are treated with an oxidizer, they form ketones. So they cannot be oxidized any further, just because there are no more carbon-hydrogen bonds. And then tertiary alcohols, if you were to treat those with an oxidizer, there's no reaction because there are no carbon-hydrogen bonds on the carbonyl carbon to oxidize. Those are the products of alcohol oxidation. Now you might ask, well, what does this matter? From a biochemical perspective, this molecule is lactate, which is the deprotonated form of lactic acid. So lactate. Physiologically speaking, if your muscles get sore from working out, or you're working out, you build up lactic acid in your muscles, and they're exported into the bloodstream. Okay? But lactic acid is oxidized not with chromate, with potassium dichromate. That's too strong. It would oxidize more than what you'd. Well, it would be fatal if you had potassium dichromate if you were to ingest it. So, but your body uses a much milder oxidizing reagent named NADH, or nicotinamide adenine dinucleotide. Okay, it's a mouthful. NAD and NAD plus, that combination, and that will oxidize the alcohol, the hydroxyl functional group, to pyruvate. Pyruvate is the predominant fate of lactate under anaerobic conditions, the conditions in your muscles when you're working out vigorously, when you're doing anaerobic exercise or anaerobic processes. So, and pyruvate go into the bloodstream, go to the liver, and be converted into glucose, which can be stored as glycogen for later use. Okay. 11 steps later, to be built up, to build back into glucose. And the whole process where you go from the muscle to the blood to the liver, whatever you have, and then back to the blood, back to the muscle. So the muscle gets glucose back. Here the muscle exports lactate or lactic acid. This is called the Cori cycle. So, and that's one application of why alcohol oxidation is important. It's how your body creates energy, for one, for your muscles to operate, at least anaerobically. But it's also a way that your body recycles and reproduces the alcohol in the polyol, the carbohydrate is where glucose is, for reuse. Anyway, if we go back and look at the summary, from back to the summary. Primary alcohols are converted to carboxylic acids when they're oxidized with strong oxidizers. Secondary alcohols are converted to ketones, and tertiary alcohols do not undergo oxidation because there are no carbon-hydrogen bonds at the carbonyl